for this problem 5, so for the certain new brand of car stereo, the demand function, the dx is 6 minus x, the supply function sx equals x squared, and the graph is given, which is nice. And as you know, as general, so the demand is decreasing graph, the supply is increasing graph, and those two meet at 2 4. But if the graph is not provided, again, use the graphing calculator to determine which graph on top, which graph on the bottom, and it should make sense that the demand should be on the top graph as the supply on the bottom. So this is the overall, or I, I could say this is the all-in-one problem that they ask you to find the equilibrium point. Point means order pair. That means you're gonna find the x at equilibrium and the price at equilibrium point. Okay, that means you're gonna set up the demand function equal to supply function to solve for x. And then for part B, you're gonna find the consumer surplus, the CS, which is you're gonna use the definite integration subtracted by the x times the p. And for the producer surplus, actually the consumer surplus, you're gonna use the demand function, okay, demand function. But for the producer surplus, you're gonna use the product of the equilibrium point and the price subtracted by the definite integration of the supply function. And the lower limit 0, upper limit the equilibrium point, lower limit 0, upper limit equilibrium point. So this is a setup. Okay, and for the graphical way, and since the graph is given, so you can see that you're gonna break it into two portions. The upper portion graph here, this area, gonna be the area that represent the consumer surplus or the amount that the customers will save based on the market price. And then the second area, which is the area below the equilibrium area there, equilibrium line. So that is the producer surplus or the quantity to represent the amount that the producers will have as an increase in revenue or increase of the income. Okay, so this one, as you understand the big picture of it, the first part, you're going to find the equilibrium point, part A, by setting up the demand equal supply. Okay, the demand is 6 minus x, and the supply is x squared. We're going to show to get the 0.2 comma 4. You have the equation with the power 2. We write everything into the same side of the equation. So we have the leading, which is the x squared term. So we're going to move everything all together, becomes the equation x squared plus x minus 6 equals 0. And then we're going to solve for x. And whatever the x that we get here is the xe or the equilibrium point. So factor again as a classic way to do it. X times x becomes x squared. 6 from the two numbers multiply. It's going to be 3 and 2. 3 and 2, the leading term. I'm not the leading term. The sum of the two terms is positive. The greater quantity gonna have the same sign. So this is plus sign, this is minus sign. So we can see that the product -6, but the sum is +1. Now we get the two values. So x equals -3 and x equals +2. X is the number of the unit. So we discard the negative number. We use the one that makes sense. Okay, we don't have the negative quantity for the unit. So that's why the equilibrium point occurs at x equals 2. Okay, x equals 2. So this is the xe. And then the following part, we're going to find the price at this equilibrium point. So the price at equilibrium point, so you can use either the demand function or the supply function to get the price. So either one, so this problem is not really matter. So I'm gonna use the supply, the S at the supply function, the S at X E, which is the square of the number. So gonna be 4. That means we have the equilibrium point as the order pair 2, 4. Okay, 2, 4. So the bar here 4. And then the next part, we're gonna find the consumer surplus, which is from, if you analyze it one piece at a time, so as a graph, the demand function is the line that coming down, and then it cut the intersection point here at the point xp, or the equilibrium point 2, 4, and the demand is 6 minus x. So what we are looking for is the area here. So this is the dx. So what we're gonna do, we just set up the integral of the demand, which is the 6 minus x. So I'm gonna repeat the setup again. Okay, subtracted by xe times pe. This is from 0 to xe. And from what we found, the xe is 2. Demand function is 6 minus x with respect to x, subtracted by the product of 2 and 4. Okay, see, that's 2, that's 4. And then what we have to do, find the antiderivative of 6 minus x. Excuse me. So this is a constant, and this one is the power with the r equals 1. The derivative of the constant is 6 times x. Derivative of the power is x to the power added by 1. The new power 2, use it as a denominator. And then evaluate from the lower limit 0 to the upper limit 2, subtracted by the product of 2 and 4, which is 8. So this is 6x minus 1/2 x to the second. Evaluate from 0 to 2 minus 8. Okay, what we have to do, we're going to replace again with the upper limit, 6 times 2 minus 1/2 times 2 to the second, subtracted by 6 times 0. Keep it as a habit to follow by the substitution of the lower limit before you forget. So this part is from the integration and then subtracted by 8. And then get the number out, 6 times 2, that's 12. This is another 2, and then subtracted by 0, minus 8. And then we get the value 2, I believe. So 12 minus 2, that's 10. 10 minus 8, that's 2. So 2 for this case is the consumer surplus. Okay. And then the next part, so I'm going to have to add more room. Let's see. Can move it down. Okay. And the next part going to be the producer surplus. Part C. Producer surplus from the supply and the market price. So the supply function, the Sx here equals x squared, and then the market price, that xe pe, the intersection point 24, and we are going to find the area here. So the setup gonna be the product of the unit, the equilibrium point unit, and the price of that point, subtracted by the definite integral from 0 to the equilibrium point of the supply function with respect to x. Got the order pair 2, 4, so me 2 times 4 minus integral from 0 to 2. The supply is x squared with respect to x. One term is not too bad. So gonna be the antiderivative of x to the third, and antiderivative of x to the second, because this is the power function with the power r equals 2. So gonna be 2 plus 1 or the power 3 and divided by the new power 3. And evaluate from x equals 0 to x equals 2. And work on the substitution. Okay, so this is 1/3. I'm gonna rewrite it as This is 1 over 3 times x to the third, just for our convenience to see the numbers, how things going. So 1/3 times 2 to the third minus 1/3 times 0 to the third power. Upper limit, lower limit, okay? And then what we get, we have 8 minus 8 over 3 minus 0. Simplify further, so 8 minus 8 over 3. 8 times 3, that's 24. 24 minus 8, that becomes 16. No, that becomes, is that right? 24 over 3 minus 8 over 3. So that becomes 16. Yeah, that becomes 16 over 3 as a result, or is about 5 and 1/3, 5.3 repeating, 5.33.